Hello everyone, this is Dr. V.V.Kamesh, Professor of Mechanical Engineering, Aditya University, Surampalem. In this lecture, we will discuss about how to draw displacement diagram. In the discussion of the cam and follower motion, when the motion of the follower is uniform with the uniform velocity or SHM or uniform acceleration and retardation. Actually, we are having another one, that is cycloidal motion, because that is mostly deviating from this earlier three varieties. We are discussing cycloidal motion as a separate one. So, these three can be discussed side by side, they can be compared easily, but the cycloidal motion we need to discuss as a separate entity, right. Now, you can see the follower is with uniform velocity, let it be, right. So, the fundamental input data I need to have is whether it is rise or return. First thing, is it rise or return? Second one, degrees. How many degrees of movement of the cam or shaft, right? How many degrees? Is it clear? So, these two things are most important, and third one is already known to us, right? Uniform velocity or SHM or uniform acceleration and uniform retardation, right? So, this is already, we are considering with the uniform velocity, this part is okay. Rise or return and how many degrees? Let it be, initially I am taking, it is rise and I am taking 120 degrees as the angle for the rotation for the rise, okay. Rise, or you can call outstroke. Return is also called return stroke only, right. There is no deviation. In the outstroke, starting with the 0 to 120 degrees with the different moments, how to draw the displacement diagram, right. Initially what we need to do is, on the x-axis I need to represent angle of rotation. So, how many degrees I need to have rise, next dwell, and one more thing we discussed earlier, once I am having the rise, immediately it needs to be followed by either return, generally we do not do it, or dwell, okay. In general 99% of case we will follow with the dwell only, right. Otherwise there is some disturbances, right. Not to have the disturbance, we will take small del, at least 5 degrees, right. Return immediately, it is not followed, not designed at all, right. We will discuss about the later, if I design the return immediately after the rise, what will happen, right. So, we will discuss later after calculations part is over. Now, coming to this one, how many degrees of the rise, next dwell, next return, okay, let it be, suppose I will design 0 to 360 degrees. So, this will be the stroke of the follower, how many centimeters, let us take, I am taking 4 centimeter, right. So, 4 centimeter stroke is there. So, immediately what I need to do is, you construct a rectangle with 360 degrees as x-axis or length, and whatever the stroke of the follower as the breadth. So, you need to construct a rectangle. So, in this rectangle, what you need to do is, you divide this rectangle into the number of parts which are defined for your rise, dwell, return, rise, dwell, return, like this, okay. So, this is the rectangle with the 360 degrees. So, this will be 4 centimeter, 0 degrees to 360 degrees. Suppose I am having a rise part in this, let it be some 120 degrees, another some 100 degrees, okay, or otherwise 60 degrees, right. 60 degrees it will be dwell, right. Next, up to 300 degrees there will be a return, the remaining thing is dwell, right, okay. Now, how can I make this part is rise, this part will be dwell, again this part will be following the motion, it is return, next I am having dwell, right. Because this is the dwell period, I need not draw anything here. So, I can write here dwell 1, this will be dwell 2, right. Now, initially I am taking uniform velocity. In the uniform velocity, actually the uniform velocity is very, very easy. So, 0 to this point I am taking B, this point I am taking C, this is O, okay. So, this is BB, this is CC, and this will be DD, this will be EE, let it be, okay. Now, from this is O to B, there is a straight line. So, I can draw a straight line. So, this is representing uniform velocity, right. But the thing is, how to transfer this displacement diagram onto the cam profile? For this, I need to divide this OB into again some parts, right. So, how to divide the OB into some parts? We can observe here at the bottom, you see this is OB is there. You divide this OB into some equal parts, right. Of course, there is no compulsion that you need to have the equal parts only. You can make unequal parts also, but the curve will not be looking in a smooth way, right. Now, I will divide this into some parts, okay, 2 equal parts, 4 equal parts. Now, it became 8 equal parts, right. So, this will be 1, 2, 3, 4, 5, 6, 7, and the last point is coinciding with the B, it is 8. Now, you draw the vertical lines from 1, right. You draw a vertical line to cut the OB at one point. Now, call it as 1 dash. You draw a vertical line 2 dash, you draw a vertical line at 3, it will be 3 dash, draw a vertical line at 4, draw a vertical line at 5, 6, 7. So, you write down here 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, all these are the intersecting points, 6 dash, this will be 7 dash, and the last will be B only. Now, these 1 dash, 2 dash, 3 dash, and these lengths you are looking at the diagram, these are the lengths you need to transfer to the cam profile, right. So, for that I need to make ready the displacement diagram so that I can copy with the compass, measure this, let it be 4 dash, measure the 4 dash with the compass, transfer to the cam profile diagram, right. So, for this I need to make ready each and every type. So, this is 1 dash, 2 dash. So, these are with uniform velocity, right. Suppose I want to have with simple harmonic motion, right. I will draw again. So, initially I will take this 120 degrees 0. Now, this is my stroke of the follower will be the vertical. Now, I need to draw a semicircle like this. What is the diameter of the semicircle? It is equal to the stroke. Now, you need to divide this semicircle into sufficient equal number of parts so that your angle 120 degrees will also be divided into same number of equal parts. Now, I am dividing this into 8 equal parts or otherwise 6 equal parts you can take, right, 6 or 8 or 12, right. So, for the sake of convenience, I am dividing into 6 equal parts, right. So, from each and every circle point, you need to draw a horizontal line along your 120 degrees rectangle. So, I am drawing, okay, I will make it 1, 2, 3, 4, 5 and 6. 6 is coinciding with O, okay, right. Now, at each and every point, you draw a horizontal line, right. Now, you divide this 120 degrees angle into 6 equal parts, right. Now, this will become 6 equal parts, okay, 20, 40, 60, 80, 100, 120, right. So, by 20 degrees it is being divided. Now, this is 1 dash, 2 dash or otherwise you can call this as 1 to 3 only, no problem at all. So, you call it as 1, 2, 3, 4, this is 5 and this is 6. Now, the point of intersection between the vertical line at 1 and the horizontal line on the semicircle 1, right, they will be intersecting at one point. You can show the pink point here. So, this is actually the horizontal line at 1, the vertical line at 1. 1 on the rectangle, 1 on the semicircle. They will intersect at the point which is required for us. It is the follower point. Now, from 2, 2 dash, 3, 3 dash, 4, 4 dash, 5, 5 dash and 6, 6 dash. So, this is clearly showing the SHM, right. Suppose the same thing, if I am following uniform acceleration and uniform retardation, there will be slight difference will be there. Okay, this is actually the rectangle which I have. let it be 0 degrees to 120 degrees. Now, if the follower is following the uniform acceleration and retardation, the construction of the displacement diagram will be slightly modified, right? So, here I need not draw any semicircle, nothing else, right? But you divide this 120 degrees into initially 2 equal parts. So, the center line will be at 60 degrees, the center line, right? Now, onto the center line, you divide this into again 2 equal parts, right? Now, remember carefully, there is a portion, I will show you with some other color, yellow line is there, the lower part of this vertical line, and this first half of you divide these two into same number of equal parts. Okay, I am dividing into initially 4 equal parts. Numbering is also should be the same 1, 2, 3, right? 1, 2, 3. Clear? Next, the remaining portion I can call this as 4, 5, 6, 7. Okay. Now, what we need to do initially, you join this first point to all this 1, 2, 3 on the vertical line like this 1, 2, 3, right. Similarly, you join top right portion line, top right we are having one point, just a diagonal corner to the O, you join this with 7, 6, 5, of course. If you join with the 4, it will pass through O only, right. Okay, I will show you again. Initially, I didn't mention, right, because this is a straight line. Actually, this line is representing the uniform velocity, right, but we are having uniform acceleration and retardation, slight deviation, right. How the deviation will be, I will show you now. You need to draw the vertical lines. How the vertical lines I need to draw? You draw the vertical line at 1, right, you draw a vertical line at 2, draw a vertical line at 3. Now, you identify the vertical line at 1 and O1, I will have one point. From vertical line at 2 and O2, I will have one intersection point. Next, from 3, 4 will be the same point. Similarly, at 5, because I will have, this is 4, 5, 6, 7 and 8. So, from 5, 5, from 6, 6, 7, 7, the last. You join all of this is the curve for your displacement diagram with uniform acceleration and uniform retardation. So, you can show this is the diagram if you draw with software. This is SHM and this will be uniform acceleration and retardation. Somebody may think that uniform acceleration and retardation and SHM, they are following the same path. They are looking like same, but they are not equal, right? There is a very slight difference. So, at the end of this lecture, student can explain how to construct the displacement diagram for follower motion, uniform velocity, simple harmonic motion and uniform acceleration and uniform retardation. Thank you.